Good morning, folks. All right, we wrapped up core early, so hopefully we'll get people here quickly. I think we should get Adam today too. I saw him this morning, so hopefully he'll make it. I suppose we've got a decent number of people here. Let's just get started. All right. I see two new PRs this week. One is from Igor. This is don't use the real whole space iterator for prefixed access. Igor, do you want to talk about that a little bit?
Yeah, that's another case which originally brought up by Corey, which is using unbounded iterators. And during my experiments, I realized that we perform full iteration over every column family for prefixes which do not belong to any specific column families. So, for instance, for shared blobs and for startfs on startup or on FSCK, it uses merged whole space iterator, and in some cases, like my sandbox, which might take tens of minutes if TP is in that degraded state with tons of tombstones. So again, the idea is to use here the idea is not to use bounded iterators, but rather use default column family. And at least in my case, this did the trick. So operations are much more fast since most of data are in different column families in the map object on all spaces. So this wouldn't rather help in regular operation, but it might help in startup.
Very good. Very good. All right. Next, there's this PR from Adam K. For Blue Star improving the fragmentation score metric. Igor, I think you reviewed that. I haven't looked at it yet, but I think it's
that's mostly about having more so it just changes the fragmentation score, how it's calculated. So initially it could not cover some spans so it was not equally spread over from 0 to 1. So
yeah.
Adam just fixes calculation.
Yeah, that was.
I don't think it's much relevant to performance at all.
Yeah, that was my basic understanding as well, that it was primarily just a fix for how the fragmentation score was being calculated. All right, let's see, moving on then. 3 closed PRs this week, all by the bot, unfortunately. So 2 different MDS PRs were closed. The first is this removing the subtree map from the journal. I'm sad to see that one closed, but it's not surprising. It's a really complicated PR, and I think, Greg, you might know more, but my understanding was that it was too much. We couldn't really effectively review it very well, and we ended up deciding to go a different route. Is that approximately right?
Which PR? I have no idea.
Oh, sorry.
Sorry.
This is yeah, no worries. This is like an old one from Zhang to remove subtree maps from the journal. I think he was going to do. I think he did maybe like a
Ah,
delta encoding or something instead. I don't remember.
okay. So they're like Zhang has many PRs which haven't merged that might get merged as bandwidth and need opens up. For subtree journaling in particular, there are like four or possibly we're up to five now that compete
Yeah.
and work together in various ways. So I think we're probably going to go a different direction there because Patrick and Shubo both have some that I think work together and that should be better, or at least are simpler to understand and maintain. Um,
Okay.
so yeah, that one I'm guessing is gone, but
Yeah. And that actually leads into the next PR here, which is uh, Patrick has a PR that the bot closed for skipping inode with cap iteration for empty directories. Um, I wasn't sure if that's one that we want to reopen or not. Maybe.
no, that one had some fundamental issues. I'm surprised it was still open to begin with.
Oh, okay. Well, the bot closed it, so it's gone now.
Yeah, 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 yep.
Cool. All right, and then the last one that the bot closed was make do write small, never do buffered writes. I don't know who reviewed this one last. Igor, did you look at that at all? Um,
Yeah, but it was pretty long ago. Yeah, I think Adam should take a look if it's still.
yeah, yeah. I know he was working on it quite a bit, but yeah, I think we need to.
The last comment is from 2021. Uh, yeah, it has since then.
Yeah.
I don't recall the details.
Well, for now, I'll let Adam know since he wasn't not here. I'll let him know separately when we talk and see if he wants to reopen it or not. All right. For updated PRs this week, the RocksDB upgrade PR. I guess the author is having issues with our Ceph RocksDB repo and needs additional help. So I told him I just briefly looked at it this morning, but I told him I'd try to figure it out. So one way or another, we'll get that upgrade. I think we really want that in for Reef. Um, Next, adding primary balance scores. Hey, do we have Laura or Josh Solomon today? Doesn't look
I'm
like.
here.
Oh, you are. I don't even. Where are you? Oh, there you are. Sorry, I missed you in the list. Go for it.
Oh, it's fine. Yeah, the updates this week were just final pushes before testing to get the balancer feature in for Reef. So we're mainly just waiting on the lab to be fixed. I think there are two PRs on there. One is for the read balance score, which is in addition to the OSD map that calculates a score for each pool, replica pool, on how balanced the reads are. And then the other one is mine, which is the overall balancer feature, and they're linked together. They each depend on each other, but they're ready to go into testing as soon as the lab can handle it. The goal
Awesome.
is just to get
Awesome.
that into Reef before the dev freeze.
Yeah. Yeah, absolutely. Very cool. All right. Let's see here then. I think we took care of the last PR in the updated bunch here. So I think the last one that I need to talk about is Igor, your faster BlueFS allocations in AVL hybrid allocators. I know Adam did an initial review of that and was not sure about it. I have not looked at it, and I apologize. I'll if Adam can't, I'll try to make time to look at it. Did you have any thoughts on Adam's comments?
Well, he didn't respond to my last comment, as far as I remember.
Yeah,
So, yeah. So it would be great if you take a look as well, since Adam, I tend to overflow Adam with my PRs, so I would.
I know. None of us have time to review each other's PRs. We make them and then they never get reviewed. I
Yeah.
have a bunch that fell off too, but yeah, I will try. If I don't, just please feel free to email me and just like hound me until I do.
Okay. Okay.
Okay, sounds good. Um, okay, let's see. Lots of stuff in the no movement category. I don't think there's anything super exciting here to talk about this week. Um, More RocksDB stuff, but we can see after we hear from David Orman's group what maybe decide if how much of this is still necessary or not. All right. Well then, actually, on that topic, uh, David or Corey, do you want to take over and talk a little bit about some of the experiments that you guys have been?
Yeah, that sounds great. Corey, I'll hand it over to you, but I'm happy to present details from our internal monitoring system. So feel free.
Yeah, so we had the cluster that had issues that we talked about a little over a month now ago with PG movement and all the deletes in RocksDB causing iterators to be extremely slow, and then the OSDs crashing due to suicide timeouts after up to like 500 seconds and stuff. These OSDs or this cluster does have some spillover of our DB from the spinning disk onto the spinning disks, and that was part of it. But we just over the past week started upgrading some of those nodes and playing with some ideas in order to work around that. And so one of the things that we deployed to the OSDs was Mark's compact on delete filter options being passed through. And the other thing was something I think I talked a little bit a couple weeks ago, which is basically passing through max skippable keys, the RocksDB read option for that from the Blue Store layer down to RocksDB when we're doing a collection list, so that I could bound the amount of tombstones that were being iterated over, and then at the OSD layer, just kind of back off and retry whenever we were seeing excessive number of keys being iterated over that were causing big latencies and ultimately the OSDs to crash. And so the results of deploying those two things were really good. In production, we basically saw the compact on delete stuff in and of itself taking care of the issue, which we were really happy about. Compactions were extremely effective in that scenario. We tested it essentially by just reweighting one of that OSD down to 90% and letting like 10 of the PGs move off of it. And when the delete work happened, we did see those compaction filters work properly to clean up those tombstones pretty much immediately, and we never had any high latencies at all. So one really positive result there that I think will be good, since that's already in main. So I think that will be a good point for this moving forward. We're upgrading the whole cluster at the moment with those patches, and at some point in the next few weeks, we'll have to move all of the data off that cluster. So we'll see, I guess, how effective it is in that larger test case scenario at that point. So beyond that, the other thing that we've realized recently, so at the time it happened, we had set the TTL compaction setting down to like an hour, I think, trying to get things cleaned up faster. And we had left that there for like a month, I guess now. And we recently realized that was really causing a lot of bad performance issues for us with the spillover. And since, as David's got the graph up there, since we set that down and we just removed it now, actually during this upgrade, it went from 95% disk utilization on those to down in the 20 percentile type of range. So TTLs, I think you have to be careful with when you have spillover based upon our experience. What else? So we also have been playing with, we noticed that the NVMe, so our NVMe volumes on these OSDs are like 60 gigabytes. And we noticed that BlueFS was only using like 5 gigabytes of that, and the rest was all spilling over. So it was very ineffective use of those resources. And we ended up finding there was the volume selector had a few tunables that we could adjust to make it use more of that. In particular, the BlueFS volume selection reserve factor that is pasted in the chat. That's default of 2. We set it down to 1, and that worked well for pushing more data onto the NVMEs in that scenario. And what we realized there is that the default logic of the volume selector basically assumes that BlueStore or that RocksDB is doing compactions according to the normal like leveled compaction settings, and that each of the levels are filling up to their requisite amounts and doing its calculations to determine how much it can move over to the fast device, even if the whole RocksDB level doesn't fit on the fast device. And in our case, with both the TTL compactions and even now with the packed on delete filters, it turns out that we aren't getting anywhere close to filling up those other levels before things are compacted down to that last level, which is L4 in our case. And so it's choosing not to prioritize moving anything over to the fast device for that reason. So there may be some other things we can do to be smarter for cases like this versus having people adjust the reserve factor to kind of detect that scenario. But we talked about that a little bit with Mark on some chat, but I think we need to think through that more. But then,
may I ask a question at this point? So I'm looking at these volume selector stats, and I could see that your log row, it shows 29 gigabyte real.
Yeah, I think there's a bug there. I looked into that briefly, but it looks like there's an accounting bug between, because like the real com is 7.6 megabytes, and that looks like it's closer to accurate. The 29 gigabytes, I think there's
maybe this somehow prevents, causes spillover to happen more early.
Well, so we have the normal RocksDB level setting, so I think 256 megabytes for level 1, which makes level 3 25 gigabytes. And we have 104 gigabytes total. So we have a lot of spillover regardless.
But I recall so you mentioned the DB volume size is around 60 gigabyte, right?
Yes.
So I recall we have some spare space for volume selector, which it attempts to not use. Maybe I need to double check, but I have a feeling that it's close to 30 gigabyte. So maybe given the improper calculation for log space plus the spare space, you might get that, volume selector might get to the state where thinks that everything else should go to slow device.
Yeah, I ran the numbers through the volume selector's logic, and I can share that with you, Igor, to show you kind of what's happening. The log issue with the accounting thing, I think might be a problem down the road, but it doesn't really get that far in terms of like thinking it has spare space to whether or not that would actually have an impact on our current situation. Because when it's calculating based upon the level sizes and this reserve factor before that, how much space it could possibly use, it comes up with like 5 GB or something. The output that David has, by the way, is the output once we do have the reserve factor set to 1.0. So when we had it set to 2.0, that was like 5 GB, the slow to dB.
And by the way, what's the exact Ceph release?
This is 16.2.10 with a few unrelated patches on it.
So it would be interesting to get more details on this GPU offline.
Yeah.
Definitely.
Yeah, I'll share some of the stuff that I was mentioning related to the actual calculations and stuff. And yeah, it would be nice to kind of brainstorm what might be a better approach for some of these edge cases like we hit where it just ends up not using much of the faster device at all. And then the last thing I was going to mention that was really interesting for us, we tried compression for both. Well, we tried LZ4 compression, and it was really effective for both the OSDs and for data, and also the RGW index OSDs, so mostly OMAP data. We got like, I think, slightly more than 50% storage savings, which for us with the spillover was really significant, and seems to have been a win-win from our perspective so far.
Have you guys seen any negative performance impact with it in any cases?
David, I don't know if you want to speak at all to that, but last we had talked about it, I don't think that we had noticed anything significant.
Yeah, no, I'm happy to answer that. We actually, if anything, we saw a positive improvement. We see more actual IOPS going on the devices that we've applied these changes to. Now, keep in mind we have applied multiple changes, so it's not just an isolation LZ4.
Yeah.
But the combination of LZ4, which positively impacted the amount of spillover, we've seen relatively consistent latency. Actually, we saw a little bit better on read afterwards. And we're seeing more actual operations completed with the reduction in latency, if that makes sense. So certainly it's been positive, but that could be a combination of the situation with the amount of spillover we had on a slow drive. The compression advantage may outweigh the performance implication, if any. And as far as like CPU and stuff, we're nowhere near even coming close to touching the capability of a relatively meager Xeon CPU. So it doesn't seem like the compression or decompression has a negative impact on that. Now it might be a different story on NVMe based storage, just because it's so much faster. But at least with rotational based storage, it seems like it's pretty much a win all the way around.
Yeah, that was kind of what I figured might be the case.
And slow devices in your cases are spinners, right?
Yeah, correct. There's 7,200 RPM, 14 terabyte enterprise SAS hard drives.
Even on NVMe, it looked like it was a trade-off. Like it was a little faster in some cases and a little worse in others, as long as you had CPU to handle it.
Yeah, it seemed like it was kind of a win-win all the way around for us. I'm trying to think if it was 24 and 25. It might have been. Let's look. Because it was pretty amazing on our index disks. Let me go look, actually. utilization. So these are basically the index pool only. When we enable compression on these, I mean, it was an enormous change. We were
Yeah.
at near 60% of, I think these were 700 gig, 750 gigs, and we dropped. It's almost, yeah, it was more than half there just because of how much OMAP and what have is there. So, anyways, that was all kinds of win on those things too. And again, you can see when we enabled it, we actually see, if anything, latency slightly better, not
Yeah.
worse. And that's NVMEs.
So Casey, I saw the best compression with this when I was doing testing last fall with RGW. I don't know if there's anything that RGW writes that's like just ridiculously compressible, but it for whatever reason it seemed like with RGW workloads we saw, or at least I saw, really, really good improvement.
Yeah, that's great. I mean, I know that there are strings in the index, but I don't have a good sense of how much is string versus other fields, but potentially a lot of other fields are like integers that default to 0, so that could help too.
Yeah, yeah. All of this is making me think that we might be moving toward compression on as the default, even just overall. We could just make it the hard drive default, but kind of feels like we might actually want it on everywhere.
Yeah, everything we've seen would indicate, especially, I mean, we can specifically speak to the rotational side. It's 100% beneficial there. Um, when it's NVMe, we don't have any pure NVMe clusters to really mess with at this point in time. So it's
Sure.
going to be hard for us to tell. Now, just so everybody's aware kind of what our process is. So we had to get all this stuff out of the way because we basically had OSDs crashing anytime we tried to do any data shifts. But we're going to take what's on this cluster, which let me go look real quick how much data this is. If it's right around 1.5 petabytes currently stored, so 2.1 petabytes used because we have erasure coding 8+3. The intent is we've just built out 2 new 21 node racks worth of servers, but those have multiple 6.4 terabyte NVMe's on them. And so those will become the new DB wall devices. So we should have more than sufficient space on the DB wall side to have everything NVMe. And we're going to add those into the cluster and shift all of the data off of this existing 21 node rack onto those other 2 that have the new device situation. So we wanted to preempt that with all the fixes and mitigations to allow us to do that without the OSDs going into these nasty little crash loops that we ran into when we had a host down for 3 days. And so that was kind of the plan. So the next step after we finish this upgrade is to just verify, validate everything looks good post upgrade. And Mark, of course, we can share whatever information you'd like. And you're more than welcome to look at the logs and anything else that would be helpful to you. Maybe you can glean some information that'll help make a decision about what you switch to as a default more clear. And then when we do the migration, we'll collect data during that process as well, so we can see what it looks like as the PGs are being purged off of the source OSDs. And then most certainly we'll have better data available on the destination cluster, which our intent is to keep LZ4 enabled. So we'll be able to collect some data there with the proper mix of DB wall and NVMe to hold the entirety of the level 4.
Yeah. And I'm pretty convinced already that I think for hard drives, LZ4 compression for XCP is pretty much a win. I think we do it. It's just the question for NVMe drives, if we just make a blanket default or not.
Yeah, that should be easy to test.
One more question is about the ratio between an amount of SDs and amount of available CPU cores or CPU threads in your case.
Oh, I'm sorry.
Igor. Yeah, go ahead.
Yeah. So how many CPU threads you have per OSD? CPU cores.
Oh, CPU cores? Let's see. So we have 48 threads, 24 actual cores. and we have 24 OSDs in these devices.
24 OSDs and
Yeah, not well. I guess if we count the
FAH
indexed
with
OSDs, it's 26 OSDs. So 2 NVMEs that we use for index pool. So that's 2, and then 24 data OSDs, which are serving the data pool for RGW.
Mhm.
And if you want to look at our CPU consumption, and keep in mind that we're in the middle of a upgrade, we have a fair bit of, I guess, spare CPU.
Right now, I have the opportunity to do some testing on very limited machines with our CPU bound. Not in any kind of real scale, but I could do some low level tests. So I think I'll try that out. But I suspect that the win in terms of reducing traffic to the hard disks is probably worth it. That
Yeah, I
SAT
mean,
2 is no NVMe, just pure hard drive.
yeah, exactly. And I mean, again, like we are in no way, shape, or form even remotely close to CPU bound with rotational drives. Like it's, I'm not going to say we're idle because this cluster is upgrading, so the customer traffic is not nearly as high as it can be. But we've never had high CPU load on this. Like I would be very surprised if we could saturate a CPU, even if the OSDs were at full 100% capacity. And
Yeah.
we could probably look. I don't know. Am I sharing the terminal or am I sharing the graphs right now?
The graphs.
Okay. Well, then you didn't see me putting all the information in the terminal showing our CPUs are currently at approximately 4% utilization per core.
Oh,
So
jeez.
there's not a lot going on
Okay.
there, but I think we've got some we may have some metrics.
Yeah.
Go look at one.
With the way that CPUs have scaled over the last like 10 years, it's
Yeah.
it's a
So
worthwhile trade-off, I think.
what I want to show you the last 2 days. This was prior to the upgrade, which puts this image in place that we're talking about. And
Oh my
so,
gosh.
and that's in the process of upgrading. So keep in mind when our index NVMEs go down and come back up, Corey's trying to dig into kind of what's going on there, but they're basically reshuffling all the data. So they're running at like 100% utilization CPU nonstop for, an hour or two while they shift data. But even with that, that's what we see. So it's like a massive drop in CPU and load. And keep in mind, some of that was IO weight, of course, like the orange is IO weight, but even like actual core consumption is definitely dramatically decreased.
Nice. Nice. Avoiding all that iteration, letting it compact and avoiding the iteration. I imagine that's a lot of it.
Yeah, I'm sure. Sure. But
Yeah.
I guess again, my point is, from the perspective of rotational drives, I find I'm very, very, I would be very surprised to see if CPU consumption got so out of hand that the LZ4 compression really made a material difference from a CPU perspective.
Yeah. Yeah. I think probably the only cases are where people are like crazy running, 60 OSDs on like 4 cores or something ridiculous.
Yeah, exactly. I mean, if someone's like super oversubscribed, but I mean, I mean, they're Xeons and they're decent Xeons. What are these? These are Cat Prog. So they're 4214s. But these are by no means like super high end vertical scale CPUs. These are more just lots of cores that are reasonable. So I would be surprised if there's a massive problem.
Yeah. Yeah. David, Joshua was asking in the chat window if you guys have a list of the things that you did, the back ports that you made or other fixes that you implemented.
Yeah, I'm sure Corey can speak to anything we've done. I mean, I can also tell you that you'll probably see me mentioning them a lot whenever we are ready to do the next release, and I'm like, make sure these go in there.
Yes, yes, absolutely. You guys are the guinea pigs here, so
Yeah.
we wanna use your experience to make Reef basically uh, the model of what you did.
Yeah, Corey, if you want to answer that.
Yeah, I will have to look back through. I think there are quite a few patches on top of 16.2.10 that we have, but I don't kind of jumping to the front of my mind here on that are specifically related to improving index OSD performance. I mean, the TTL, getting rid of the TTL that we had in place for TTL compactions definitely seems to have been an important step in improving their performance there. And I'll look back through the list of patches that we do have on top of this to make sure there was nothing else related. Trying to think, the compression seems to have helped some with performance.
I think a lot of this is really about mitigating the stuff that was causing us pain in terms of shifting data, crashing OSDs, and they all kind of had knock-on effects. So as we were trying to address kind of the root cause, we just saw that, oh, hey, we can't not have TTL-based compaction on when we have this, deletion issue that causes the OSDs to lock up to where they get a suicide timeout. So as we've implemented patches that have allowed us to, we started by reducing the TTL, or I should say increasing the TTL compaction time. So we were at every 1 hour previously, then we went to every, I think it was 6 hours, and now we're just turning off TTL compaction. So a lot of the performance increase is because we've been able to remove things that were actually punishing, I guess, the OSDs rather than helping them, but were necessary in order to prevent the cluster from eating itself, if that makes sense.
Yeah, okay, thanks. That does make sense, yeah.
Yeah, and there were some changes we made, that might have some performance implications, certainly, but a lot of it, I think with Mark's patch, it may not be as beneficial as it once was because now we have really efficient compactions.
Sorry, Mark's patch being his RocksDB settings, the new ones that are in main?
Probably more so than the settings is the compact on iteration stuff, right?
Gotcha. Okay.
Yeah.
Correct.
Yeah, we didn't even change. I don't think we even changed the other settings. We just backported the compact on delete stuff. And we did set those compact on delete settings a little bit lower than what you had, for now at least, while we're trying to move data around. I think we have both of them set at 512. So anytime there's 512 consecutive tombstones in an SST file, it marks it for compaction right away. We'll probably bump that up a little bit after we get a sense of after we play with it a little more, but that's what we're starting with here.
Sure. I just kind of picked those out of the blue, based on what seemed reasonable, but testing is much more important.
Yeah.
Very cool.
Thank you. Yeah, thanks.
Guys, this is really great. I think Reef is potentially could be one of the best releases we've made in quite a while. And in large part thanks to all this testing you guys are doing. So really, really appreciate it.
Yeah, and to be clear, we're running Pacific, right? I think this is all great for Reef, but we should definitely give a lot of thought into where this lands backported to, because a lot of people would stand to benefit from this too. And I know it's really nice to be able to sell the story of hey, if you upgrade to Reef, it's going to be way faster and way better, which is harder to sell if people already got a lot of the benefit out of some of the earlier releases. But at the same time, I mean, clearly we're able to do it on Pacific. Our intent is to move to Quincy next. I think actually after the next release is kind of the plan currently.
Sure.
But we certainly want to see all this, at least as much as makes sense and is prudent, backported. Now, changing the defaults, that's probably a different discussion, and that might be something that you could do Reef specific or what have. But I think a lot of users would definitely benefit from this, just in general.
Do you guys upgrade RocksDB too, right?
No, we're currently running the version that's distributed with Ceph. We're not running the Tree one. This is just running the one that's already in Pacific. So it's just Pacific plus, I think there's 10 or 15 patches or something that we're maintaining for various things.
Okay, sorry, I misunderstood. I thought you guys would upgrade RocksDB too. Okay, well, good.
No, it may even get better with RocksDB, right? That might even be awesome. No idea.
Yeah, they've got something in the new release that helps improve the behavior of tombstones in the mem tables. So that thing I did was just for the SST files, but it doesn't help you at all with mem table tombstone accumulation, which maybe we don't hit. I don't know, but it sounds like the new version of RocksDB is definitely worth getting in if we can.
Yeah,
And
I mean, I read through the changelog, and there were like so many thousands of bug fixes and other things, some of which sounded relatively disastrous and might
I
account for some
know.
strange behavior that we've probably seen in the past. So, it's like everything. There's little risk, but I think the reward on that might be worth it.
Yeah, we need to get baking soon, as soon as we can into Ethology, so that for Reef we feel confident, and then for Pacific and Quincy backports, that's scarier for me because they change a lot of stuff in RocksDB, so it's maybe. But
Well, I think
hey,
that might be the right compromise, right? Like do it
yeah,
for Reef with the RocksDB upgrade, and then just now that we've got some data, and we'll continue to collect data and share whatever is useful to you. Maybe we could look at just tuning some of the settings, or giving people the option to upgrade and tune the settings to get at least some of the benefit.
yeah, exactly. I mean, it looks like with stock RocksDB and just a couple of these fixes, you're seeing like dramatically better behavior in Pacific. So
Right.
I think it's worth it. Well, cool. Thank you guys. This is excellent. Any other questions for David's team? All right. Well, Joshua, I moved your stuff up because it's more important than what I wanted to talk about. So why don't you take the floor?
Yeah, I mean, I can talk about it. It's almost more Igor's story to talk about now than mine, I think. But thanks to insights from Igor last week, he and us have been digging further, and we're at this point, I'd say we're fairly certain we know what the cause of the write amplification is. Maybe not down to like the very precise change, but basically, what Igor has found is that there's gigantic inodes in BlueFS, like 600 megabyte inode, for example.
Whoa!
So the extent list for this inode is just gigantic. And because of the way BlueFS log works, is every single time that extent list extends, it's rewriting obviously the entire inode to the BlueFS log. And so the log is just being hammered, both by writes and also just by compactions because the log gets so big. So that's actually, and so the inode that's getting that big is one of the RocksDB walls. In the particular case I looked at, it was for the L column family. I don't know which of that one stores. And that's actually expected because the Pacific setting says don't let the walls exceed 1 gig in size. So I guess the question is, like, what was the behavior under Nautilus? How big could those walls get? Because that setting was added in Octopus or Pacific. I think it was in Pacific, had something to do with the sharding work.
Yeah. Adam added that for his stuff.
Yeah.
I thought that was just the max. I thought that just limited the max size.
And I guess we're just getting up to that max size because we're seeing 100, 700 megabyte wall logs.
Okay.
Well, in my experiments with Vstar cluster on the same Pacific release, I could see something like 250 megabyte as a regular cap to wrap thread headlock. So, but maybe in some access patterns it might reach up to 1 gigabyte indeed. And I'd like to mention that another key factor here is that DB shares the main volume, and hence we use 64K location size for BlueFS, which makes the extents much less, and the allocation map is of this large red headlocks. That's the issue. Yeah, not to mention that Pacific.11 has fixed for that, so it shouldn't happen.
So each buffer is supposed to only grow up to a maximum of 256 megabytes in Pacific. You're saying that one inode was like 600 or 700?
I have a feeling that it might be relevant to a different column family sharding. Since this was backported from Nautilus, DB could be less sharded, and maybe that's somehow relevant. But just a hypothesis. Or maybe the access pattern is that interesting.
That's odd.
But anyway, having 250 megabyte in write-ahead log, 64K allocation unit might trigger pretty large BlueFS log updates as well. So in .11 and in main branch, we use incremental updates from now on, so that's not the case anymore.
Okay.
Yeah, so Igor had recommended 2 experiments. Obviously, one is testing 16.2.11, which we are planning to get into the lab hopefully in the next couple of weeks or so. We don't have a hard plan on that yet, but this might move that up. The other one was just like as an interesting, what happens if we crank the BlueFS shared alloc size from the default 64K when it's on the same device to 1 meg. And so I ran that experiment this morning, and it does seem to make a pretty big difference. I don't have the data to look back on this particular system to say, is this now back to the levels we used to see on Nautilus? But the BlueFS log byte stat, for example, is much better behaved in that mode.
I'm curious if the new tunings that we have currently in main would help too, where we have a lot more buffers of smaller size, and we deal with the ramplification in the database in a different way by having L0 and L1 more closely sized with each other. I'd be curious if that changes it as well. Might be justification in Reef for leaving the new tunings in place rather than reverting them.
Yeah, so that's something that we can potentially play with. The other thing is, like, do we actually need to let the RocksDB walls get to a gig?
It's good if you have enough backend throughput to want to absorb a burst, right?
Okay.
Without throttling.
Gotcha.
But the fact that you're seeing it get up to that makes me think that your compaction is not keeping up.
Well, this system is practically idle.
Really?
Like it has very little load going to it.
I suppose it's because each column family allows accumulation of 256 megabytes, and then you compact when you hit a gigabyte. I bet that's what's going on. Like it used to be, right, that with one column family, you'd write into a mem table for everything, and then once you hit 256 megabytes, then you would start the compaction process and you'd start writing into the next one. And that would be, if you're on an idle cluster like this, you'd compact it really fast, then you're writing to the next one. You'd never, in practice, ever exceed like 256 megabytes. But with column family sharding now, I imagine, if I remember right, I'm a little fuzzy on this, but I think you have the ability to write into buffers for every single column family, and you might allow yourself to get very close to that 1 gigabyte limit without ever compacting any individual mem table until you hit the global limit, and then you're like, oh crap, now I'm going to compact early.
Gotcha.
I think that's kind of how it works. Maybe that's what it is. But they should be separate files. I don't understand why the inode is like 700 megabytes. Is it?
Yeah, what goes into the L column family?
Let's find out quick. We'll go look it up. Sorry, my keyboard's loud. I'll mute until I figure it out.
L refers to deferred rights. Well, it definitely makes sense since you have.
Okay, deferred rights, that actually makes sense because I was just thinking through, I'm looking at this cluster and we have, just like in the nodes that have 4K MAS, we're definitely showing less bad behavior than the ones that have 16K MAS. I think.
Yeah, I'm still surprised by that, but Igor, do you remember Sage had that PR for RocksDB to be able to reuse existing files, and that got blown away because it wasn't safe for the write ahead log.
Yeah.
I don't remember what the behavior is that we revert to when we're not doing that. I thought we just created new files for every single mem table.
I'm not sure we control creation of this write ahead log file up to RocksDB. But I suppose we've never been monitoring the size of write ahead log. So maybe that's pretty regular case,
This is another case, Igor, where I feel like we should get your write ahead log working.
Well, again, that's not a big deal if we use incremental updates in BlueFS log.
Yeah.
The issue is that the inode is pretty huge, and jumping into log on every DB transaction is pretty costly. And
Yeah.
by estimates is something like the allocation map might take 50 or 60 kilobyte. Imagine for each 4K write, you get 60K update in BlueFS log, which is crazy. And once we have incremental updates, it should be.
Yeah. It's kind of interesting to me that it's not completely unrelated or different than the issue in CephFS with encoding the subtree map for every single journal, right? Like this feels like a repeated problem we have.
The same design pattern. Yeah,
yeah, exactly.
You might want to try the same design, the same fix then.
Yeah, exactly. All right. Well, Igor or Corey, or sorry, no, Joshua, were there any other things there to talk about before we wrap up?
I guess from my side, yeah, look, we'll be reporting back on the ticket to see what 16.2.11 gives us in terms of
Okay.
improvement here. I mean, overall, despite this, I think we saw an improvement from a Pacific install, and like this was probably across like 24 production clusters or something like that. I think we saw improvements in pretty much all of them except one.
Good.
So, like, despite this, Pacific is still really good or better from a latency perspective. And so, hopefully, once this is solved, maybe that last one will come in line, and then it'll be just a straight up improvement across the board. But we'll see.
Good. I'm very much hoping that when you guys look at Quincy, you'll see another improvement. There's a couple of things in there, but especially Gabby's work with.
Yeah, I was thinking of Gabby's work. Yeah.
Exactly.
Yeah. I'm looking forward to that. I'm suspecting we're going to jump straight to Reef.
Sure.
Based off
Okay.
of our internal workloads and timelines. So that will probably be what we do. But who knows? Maybe we'll go to Quincy first.
Cool. All right. Well, I don't think we have time to talk about hard drive stuff here, which is fine since Adam's not here anyway. So we'll push that after next week. But any last minute things from anyone before we wrap up? All right. Well then, hey, thank you, Joshua, and thank you, David and Corey. This was an excellent meeting. Really, really excited to see things getting fixed here. I think Reef could shape up to be really good. So, I see David had one last comment.
Awesome. I'm
Yeah.
so glad to hear that, David.
We were in a pretty nasty place, and that tool made it a lot easier to deal with manual rebalancing to get ourselves out of hot water. So seriously, that was like a massive help. So just want to say thank you.
Awesome. I'm so glad to hear that. Yeah, we built that tool internally to get ourselves out of massive piles of hot water. Stuff I can't even talk about, unfortunately, but once we were done, we felt like it was worth open sourcing. So I'm so glad to hear that. I've been happy to see on the mailing list too that people are using it.
Yeah,
Can we get that built into the distribution? Would you be willing to get it in? That sounds like something we need.
Well, we need to fix the current balancer. I think that's the real
Sure.
answer, right?
Yeah,
Sure.
I mean, so it's interesting you say that, Mark. So I actually thought once or twice about actually rebuilding PG Remapper as like a Ceph Manager plugin, essentially.
Yeah.
But ultimately, and I actually had a Cephalocon presentation lined up for this last year, but with all the shuffles, I just didn't get it on the schedule. But ultimately, what I actually want to do is I have a list of, I think, 3 or 4 points that if we fix those, then we actually don't even need the tool anymore. And most of it has to do with backfill scheduling. So, anyways, that it would be an interesting topic. Build into the distribution, sure we could. I'd almost much rather just hey, can we spend the time to fix the things that caused us to need PG Remapper in the first place, if that makes sense.
Sure. Yeah. Sure.
Yeah. But some of those are not easy problems to solve. So.
Yeah. Are you coming to Cephalocon?
That seems unlikely.
Okay.
Like many places, travel budgets are tight.
Yeah.
But I don't know. Maybe I'll resubmit the talk and see if I can get some budget scrounged up for one of them.
Sure. We're doing New York in 3 weeks, but that's pretty short notice. I don't know if that's for the Ceph Day.
Well, it's funny because we're a New York-based company, but I'm not in New York, so.
Oh, okay.
It's still travel for me in the end of the day.
Yeah. All right. Well then, let's wrap up here. Thank you guys for coming. Great meeting. Talk to you next week.
Thank you.
Okay, thanks all.
Yeah,
Yep.
thanks. Bye.
Bye everyone.